In the last section, we started up a separate server that serves raw JSON data. The idea here was to get some experience where our GraphQL application pulls in data from an outside server rather than using the static data that we are currently using, which is the hard-coded list of users inside of our schema file. The two things I want to point out to you, just to be really clear about the JSON server, is that if we go to localhost :3000/users, we get a list of all our users. And then if we go to /23, that will give me the user with ID of 23. I could also go to 40, and there's my user with ID 40. Do note as well that this is running on a completely separate port from our GraphQL instance or from our graphical instance. The other one is running on localhost 4000. The server that we just started up is localhost 3000. So two completely separate, disconnected servers, completely separate. All right, with all this stuff in mind, let's open our code editor and check out our schema file. So here's schema.js. In our schema file, I'm going to scroll down to our root query towards the bottom. Inside of here, we are still making use of Lodash to search through the local list of users we have. Remember the purpose of resolve. It must return the data that represents a user object. Right now, it is returning the user directly in a very synchronous fashion. So when resolve gets called, boom, we instantly return a user. The resolve function, however, can also work by returning a promise. So it can work in asynchronous fashion. If we return a promise from the resolve function, GraphQL will automatically detect that we've returned a promise, wait for the promise to resolve, and then once it does, grab the data that it resolved with and send a response back to the user. So in practice, once we make a request or a query from our graphical interface, it's going to go to GraphQL. GraphQL is going to reach out to our JSON server and say, hey, I'm looking for user 23. And that is, of course, an asynchronous request. It is an HTTP request to go out and reach to this other server. The JSON server will then respond and say, hey, here you go, here's user 23. GraphQL is going to wait for the request to resolve, and then it's going to get the user back and send it back to the response to the graphical client. So that's what we're going to do inside of this resolve function. Nearly all data fetching that we're ever going to do inside of a Node application is asynchronous in nature. So we nearly always end up having to return a promise from this resolve function right here. Okay, so I think we've got a plan to move forward on. We need to make an HTTP request inside of this resolve function right here and return the promise that it generates. To do so, we can either use the native fetch function, or we can use the library Axios. And remember, fetch and Axios are both used for making HTTP requests. If you've taken any of my courses before, you'll know that I'm a huge fan of Axios. I am not a fan of fetch, so we're going to go with Axios. Let's get to it. Axios is a third-party library, so we are going to flip back over to our server and make sure that we install it as a dependency. So inside of my server directory, I'll run npm install --save Axios like so. And it's a really small library, so it should only take a second to install. There we go. Now back inside of my schema file, I'm going to import Axios at the top. We don't need Lodash anymore because we're not going to be going through that static list of users. So I'm going to replace the Lodash import with a require statement for Axios instead. We're not going to use the static list of users anymore, so I'm going to delete the static list of users. That can go as well. And then we'll go on down to the resolve function. I'm going to take out the existing statement that's in there, and we're going to replace this with a request over to our JSON server. So inside of here, we'll say return axios.get, and then we want to make a request over to localhost 3000/users/ID, or the ID of the record we're trying to find. To do so, we're going to use a ES6 template string. So I'll put a backtick down, HTTP localhost colon 4000, or excuse me, 3000. Let's make sure we get that right. Slash users slash $ curly braces args.id, like so. Again, this is an ES6 template string, so do make sure that you have backticks right here on either side. And we are making reference to args.id. Remember, the ID is coming in from the query when the query is made. All right, this is looking pretty good right here. We make the request and then we return it. So GraphQL is going to wait for the promise that is generated by this request to resolve. Once it resolves, it's going to take the data and send it back on down as a response to the query. Now there is one little gotcha in here, okay? One little gotcha. And this is kind of an oddity of Axios working with GraphQL. When Axios's promise resolves, so if we put on like a .then, and we take the response and we console log the response like so, we get back something that looks like this: data, first name of Bill. So the response object that Axios returns has the actual response data nested on this data property right here. It is nested on it, and that is just how Axios chooses to respond from HTTP requests. It nests the data on this data property. Now the bad news is that GraphQL does not know that. It does not know that the data is nested on this .data property. So just to make Axios and GraphQL work together, we're going to do just a little bit of finagling with the response before it goes on to GraphQL. So we're going to say resp.data like so. So what this does is it says make the request, and then before anything else happens with the promise, like before any other function gets tacked on to this promise to be resolved, take the response, return only response.data. So anyone else who chains on this promise, like with another .then, they would only see the data that came back from the response. So in other words, we're just paring down the response object that comes back from Axios. I know this probably seems a little bit confusing, a little bit arbitrary, it's a little bit painful. Yes, I agree, but it's what we have to do to make Axios work nicely with GraphQL. In the future, we will wrap Axios with a nice little request handler, and so we won't have to deal with this all the time, but we'll take care of that in the future. Okay, I think we're ready for a test now. So I'm going to go back over to my terminal. I'm going to start my server back up with node server.js. I get the listening message, which is good. And it appears that my JSON server is still running as well. So everything is looking pretty good at this point in time. Let's go back over to graphical. So I'm on localhost :4000/GraphQL. And we'll make the same query for user 23. We run it and we get back Bill. Okay, that's great. Let's look for user 40. Remember, for me, I had made user 40 inside of that db.json file. So inside of db.json, here's user with ID 40. If you used any different IDs, you'll see a different ID here instead, and you'll want to use a different ID as the argument to the query. So I'll look for user with ID 40. Again, yep, it looks great. We can check out our terminal, and inside of here, you'll also notice that we see the request logs from our GraphQL server reaching out to the separate JSON server to fetch these independent records. Okay, so not too bad, not too bad. I really like how this is going. We've split off our resolve function to reach out for some data from some third-party service. The key thing to keep in mind about resolve right here is that because it can handle a promise, we can really fetch data from anywhere you can possibly imagine. This can be a third-party server. This could be reading a file off the hard drive. It can be a database, anything we want to do. Resolve is really our playground for just fetching any piece of data in any fashion that we can possibly imagine. Okay, let's move on to the next section and start putting a bit more logic into our queries.